Welcome back to another session of Educator.com, Introduction to C++. Today, we're talking about operators and expressions. More operators and expressions, but you need operators for your expressions. Okay, quick overview. Operators we're going to be looking at. Operators you can kind of look at them as kind of functions. They take two parameters, one on either side. We have assignment operators, arithmetic, comparators, which say, is this one greater than that one? Booleans, is this true or is it false? And the precedence of operators, and some expressions that put all the operators and values and variables together so that you can get an additional value. A little bit about type promotions and a few cautions to be on the lookout for. All right, now, operators work on their parameters and they return a value. So most of them have got two parameters. You've got A plus B. Plus is the operator. A is the one on the left. B is the one on the right. It returns a value that's equal to the left side, A, added to the right side, B. That may seem straightforward, but it gets more complicated later. Some operators, like this one, is a unary operator. It has just one parameter, returns the value on its right side. And in this case, it negates whatever that value is. If it was a positive number, it makes it negative. If it was a negative number, it makes it positive. And we do have a ternary operator in C and C++, where we have an expression which is evaluated for truth or false. If it's true, it returns the value of the first one between the question and the colon. And if it's false, it returns the second one. Now, the left side and right side is important. You get different results based on what your left and right values are. Some things you get the same things, like, okay, plus and multiply, for example, called commutative operators. A plus B is the same as B plus A. Okay, 2 plus 3 is 5. 3 plus 2, still 5. Subtract and divide, we get different results. A minus B is not the same as B minus A. And this distinction is also very important for the assignment operator. A lot of newbies will make this mistake when they're first writing code. So you have A equals B. That's a single equal sign. That's an assignment. That's not a comparator. Is A equal to B? It's not a algebraic equation where you say A and B happen to have two equal values. No, that is taking the value, the expression of B, and assigning that to the variable A. If we reverse those, it does the exact opposite. It takes whatever's in A, assigns it to the variable B. In this particular example, we have a literal, 17, a numeric literal, and we're assigning the value 17 into A. And I see this in more newbie codes. We try to do the reverse of that. No, it won't work. What this is saying is take whatever the value of A is and assign it to 17. 17 is a literal. You can't assign it to anything. And it won't assign the opposite direction. So you can't do this. It's just totally illegal statement. So again, we'll do a little bit more on our basic assignment operator. It's a single equal sign. In C and C++, there's also a double equal sign. It has a completely different meaning. So here we have some expressions. We have int has been initialized to 5, or excuse me, A is an int initialized to 5, B is initialized to 10, C is initialized to 25. So we can print out B is, and it will print out the value of B. So we'll get 10 will be printed out. Now we're saying, now we want to change B. We want to take A, apply the operator plus and to C. So C is 25, A is 5, 5 plus 25 is 30. If I get my calculator, yep, that's what it is. And so now we can say B is changed to B, so now this should get a 30 printed out. Now we say, oh, here's another thing. So folks sometimes get confused and say, it's impossible for A to be equal to A plus 1. It's not an equation, it's an operation. What this says, take the value of A, which is 5, add 1 to it. So 5 plus 1 is 6, and now assign that to A. So A is not 5 anymore. Now A is 6. Now, a real quick thing on confusing your readers. It's more important that your code is readable by humans than it is to be readable by the computer. The computer doesn't care what you do. It will try to interpret as best as it can and do what it thinks you want to do. But more time is spent with a human looking at code, trying to debug it, add features, whatever else, than it is for the computer to run things. So you'll see this kind of code all the time. And it's not always a bad thing. I don't like it. A equals B equals C equals 17. Now this is an operator. It has a left side and a right side. The left side is called the left-hand expression. And it has to be a variable where you can store the data. The right-hand side is a value expression. If there's a variable there, we'll find out what that variable is equal to. And so we have here C is equal to 17, and we're setting B equal to that. So the C equals 17 not only sets 17 to C, but evaluates to 17. So now B is equal to 17, and A is equal to 17 by the same logic. But, and of course, this is my opinion. You'll see this code all over the place. Some people like it. They think it's great. I don't like it. I prefer this way because you declare int. You can put a comment right next to it. B, beta, gamma, and I just came up with some random comments. And then C equals 17, and then B equals C, and then A equals B. So that's a little bit clearer. It's easier for a human to read. Even better is don't use a 17 like that. This is what's called magic numbers, where you actually just put a number in there. Nobody knows what the number is for, but it's magic because the code works. But have initial value. Have a variable that says altitude of elevator at the start. So int A is your first elevator, int B is your second elevator. You set them all to the same value this way. So I have some comment here to describe why we chose 17 for this particular value, and I declared it as a constant because I am not going to change it for whatever reason. Now you might come and recompile it later and say, well, we discovered it can't be 17, it has to be 16. Well, that's fine. You change it in one place and all the other ones will get the new updated value. So we've got some arithmetic operators. Add, which everybody knows about. You add 2 plus 2. 20 plus 10 is 30. 10 plus minus 30. This is a unary operator. We're taking the minus, making 20, making it minus 20. 10 plus minus 20 is minus 10. Subtract. 20 minus 10 is 10. 10 minus 20, of course, is minus 10. Multiply. 20 times 10 is 200. Divide. Now you don't have this operator. There's a couple of points here. You don't have if you're used to algebra, if you're used to doing your algebra and reading your algebra from books and writing it on paper, you don't have the period as the multiply operator. It's the asterisk. You don't have the division sign for division, basically because early keyboards didn't have those keys. So we have the slash as your division operator, basically because this is your typical fraction. This is as close to that fraction as you can get. And you don't have this as dividing the other direction. No, don't even worry about that. And one that you may or may not be familiar with is the remainder. That's a percent operator. It kind of looks like the divide tipped over, but that is the percent operator, which takes the remainder. So 20 divided by 10 is 2, remainder 0. 25 divided by 10 is 2, remainder 5. This is called the modulus operator. Now we have compound assignment. In C and C++ add this. You don't have to say A equals A plus 7. You can say A plus equals 7. So you've got 5 of them. You've got plus equals, minus equals, multiply equals, divide equals, and remainder equals. And they each do the same thing. It's the same thing as having, okay, C divide equals B plus 5. That's the same thing as saying, putting this in parentheses, and C divided by this expression. And then assigned to C. And it's kind of useful stuff. It's a quick shortcut. Everyone who's familiar with C and C++ knows how it works, so it's not a real big deal. Increment decrement operators. You have 2 pluses in a row or 2 minuses in a row. This requires a left-hand side expression. It requires a variable. And it adds 1 to that variable for the plus plus, or subtracts 1 for the minus minus. And again, it requires a variable, it requires a left-hand expression. Here's some examples. A is 0, we set B to 2. Here's A plus plus. So now A was 0, we're adding 1 to it, now it's 1. B minus minus, it was 2, we subtract 1 from it, now it's 1. So now they're both the same. And again, you can't do something like this. This is a literal value, evaluates a right-hand side expression saying plus plus. You can't do that. No, don't do that. And there's pre and post increments with these variables. It's something to be careful of. It's something you need to know about. What it does, the pre will first add 1 to the variable and then reference it. The post operator will reference it first and then add 1 to it. So here we have, C is 0. So we're going to add 1 to C, which makes it 1, and then we're setting D to 1. In this particular case, now C has already been set to 1, so now we're going to set E to 1, and now we're going to increment it again, so now C is 2. So you notice that both D and E have been set to 1 based on the pre versus post increment. That confuses a lot of people, so I recommend you try not to depend on that in your code. And we have comparator operators. We've got our double equals, which means this side is equal to that side. Here we have an example. 7 equals 7 evaluates to true. Or we have not equals, because the bang, the exclamation point, sometimes called a bang, means not. Greater than, the left side, or my left, is greater than the right side. So better look at it from here. We have this is greater than or equal. So 9 is greater than or equal to 7, evaluates to true. So these are all compared to this. This is greater than or equal, less than or equal. Now here's a quick example. We have int A is set to 15, B is set to 95. So A, is that less than or equal? Is 15 less than or equal to 7? No, so that's false. Is A not equal to B? Yes, that's true. It's not equal, so that's true. Is A greater than B? Is 15 greater than 95? I don't think so. That's false. We have logical operators. There's the exclamation point, which means not. Like in modern parlance, we call that as a short. We call it bang. So it's a cute thing to remember. 2 ampersands is a logical and. This and that. 2 vertical bars is or that. Most modern compilers for C++ will allow you to use keywords, not, and or. It makes it a little bit easier to read, a little bit more understandable. So this is and, or. It compares the truth of the left expression to the truth of the right expression. Bang reverses the truth. If it was true before, the bang makes it false. If it was false before, the bang makes it true. Some examples. True and true is true. So if the left-hand side is true and the right-hand side is true, then the expression this and that is true. True and false is false, because and requires both sides to be true to evaluate the true. True or false is true. It is either this or that. If either one of them is true, then the expression is true. False or false, both sides are false, evaluates the false. Not true, that's a good one, it's false. Not false is true. Here's a quick expression, true and false will evaluate the false, not false will evaluate the true. We have some Boolean variables here. Bool A is set to true, bool B is equal to false. So A and true. A is true, and true is true, not true is false. A or B, either one of them is true, it evaluates the true. Now, in case you're not familiar with this, it uses Boolean algebra, Boolean arithmetic, and these are what are known as truth tables. You have A or B evaluates to, if in this column, or this column evaluates to that column. So true or true is true. True or false is true. False or true is true. False or false is false. In other words, for the or is false if both sides are false. If either side or both are true, then it evaluates to true. And both sides have to be true in order to evaluate the true. So here we have true and true is true. True or false, false or true, false, true and false and true, false and false, all evaluate the false. And the simplest one, of course, is the not. If not true is false, not false is true. And some examples, semi-real world, we have a Boolean value called movie discount. We want to find out, is this person available to get his movie tickets at half off price? Well, we want to find out what the user's age is. If it's less than or equal to 12 or greater than or equal to 65, then he gets a movie discount. This is the young age discount. This is the senior citizen discount. If your age is 15, 15 is not less than or equal to 12, so this is false. 15 is not greater than or equal to 65, so this is false. False or false is false. So the 15-year-old does not get the movie discount. Sorry, guys. In the same vein, we have allowed in an R-rated movie. Get the person's age. If that person is greater than or 18, or we have another Boolean variable which is declared and operated on somewhere else, he's with the guardian. If he's with his legal guardian, then okay, if it says okay with him to bring it into the R-rated movie, then bring him on in. So if he's greater than or equal to 18, or with a legal guardian, then they can come in and see the R-rated movie. We have may vote. Is he allowed to register to vote? What the laws are at this point, if you're greater than or equal to 18, you can vote. But you can't vote if you're a convicted felon. So you may vote if your age is greater than or equal to 18 and you're not a convicted felon. So if you're a convicted felon, then not convicted felon will become false. So false and anything, you can't vote. Now we have our input and output operators. This is called the insertion operator. This is called the extraction operator. So the left side has to be an I/O stream, such as C in, C out, C error, C log, etc. So you have your output stream, your insertion operator, then an expression. So what this does is it takes that expression and inserts it into the output stream. The other direction, we take the input stream and extract from it and put it into a variable. So the expression value is an I/O stream such as C out. Now here we have C out, it goes left to right, C out. So it takes A, inserts it, and returns an I/O stream. It returns output. This expression returns an output stream as its result. And that output stream then gets B sent to it. That returns a result, which is the output stream, and that gets C output. And that's how you do this. It'll go A will be sent, then B will be sent, then C will be sent. So it's equivalent to this in parentheses, then that, and then that. Now, it just happens, we're not going to cover this in this class because this is kind of advanced stuff, but it happens to be an overloaded operator with the bitwise shift operator. So if we have a character and we set it to 2, this is the bit pattern for the number 2. And if we apply that bitwise shift to it, it will shift it over 2 bits. So this 1 was in this position, we move it over 2 places, and now that becomes the bit pattern for 8. And if you print it out as an integer, it will print 8. You can do some typecasting and size of as an operator. Each type can have an explicit typecast. So the C style is to put the type inside parentheses in front of the item to be typecast. So we take pi, which you set to 3.14 as a floating point number, and we're casting it into an integer. So we only want the 3 part. C++ style, you can use that, or it can say int, like a function call, and put the expression to be evaluated, to be casted, and we get the same results. Here we have an example. We have a floating point 65 point A. We're casting that into a character. It will throw the 0.8 away and then convert the 65 to the ASCII value of 65, which happens to be capital A. So when we print this out, we'll get a capital A printed out. Size of the operator. It acts kind of like a function, but is really considered an operator. Here we have an integer num, which the integer happens to be 4 bytes in size. Here we're declaring 20 bytes for the character string. So we say the size of num will get 4. Size of this particular string will get 20. And this can be convenient for allocating memory. We'll have an object, a structure, a class, whatever, and the compiler knows from its compilations how big that particular object happens to be, how many bytes it takes, and we need to allocate some raw memory for it. So we use the size of to find out how big that object is. Some things to be worried about. Just moving, it's not just typecasting, but whenever you're changing type from one type to another type. Here's a classic example. We have 1.0 divided by 3 put into the floating point f. It will be set to 0.33333. That's just as many 3s as the float can cover. It's actually 33333 off to infinity. That's the real number. But obviously, we have a finite number of bits to represent the number, and this is how far it gets with the floating point. Here we have g. We have the same thing. We have 1 divided by 3.0. This one was 1.0, so this was the float, and this was an int. So the int is automatically promoted to a float in order to make this arithmetic. Now here's where you have to be worried. 1 integer divided by 3 integer is 0, remainder 2. So, but we're not looking at the remainder here. So with this, h will be set to 0. And this will confuse people. Say, I said 1 divided by 3. Why did you give me 0.333? Well, no, because you asked for integer arithmetic here. So if you want to get the 0.333, at least one of the expressions has to be promoted to a float before you do the arithmetic. And we have explicit or even implicit typecasting. Here we have integers being set to 75,000, and then we're casting it to a short. Now, a short is only 2 bytes. 2 bytes will only go up to 65,535, which is smaller than 75,000. And the compiler won't warn you about it. It just assumes you know what you're doing. So when you print this out, you will get 9464. You say, wait a minute, why aren't I getting 75,000? Because you didn't give it enough memory to store the full number. So we typecast from the smaller type, you'll get truncation. So we have the floating point 10.9, NA is a negative A is minus 10.9, NA1 is minus 10.1. So we print this out, we'll get a 10. NA gives you minus 10. It doesn't round it to the lower number, which would be minus 11. It just takes the fractional part and just throws it off. We have, if we add, we're going to do rounding, we add 0.5 to it. 10.9 plus 0.5 will be 10.4. When we truncate that, that'll be 11. So when you're doing rounding 10.9, you want to round it to the closest. This is a good way to do it. But you have to be careful. It may not be what you want, particularly for negative numbers. So be very careful when you have negative numbers. So when you're in doubt, try to keep all your types as the same. If you're going to be working with floating point numbers, make sure all your numbers are floating point. If you're working with double precision, make sure all your numbers are double precision. Because when you mix your types, if you don't know exactly what you're doing, it might cause problems. And we saw a little bit of type promotion there. If you have an expression, you've got some smaller types and they're all in the same expression with larger types, the compiler will say, well, this is a small number. If we have to make it a big number in order to do this arithmetic. It's usually done automatically, especially for the simple built-in types. Here's an example. We have a char. We're defining it as capital A, which, as we've seen before in ASCII, is a numeric 65. We have integer I, float F. I set to A. The character A is promoted to the integer 65. As a character is only 1 byte long, it would be between 0 and 255. The int, now, it can be between 0 and 2 billion and something. Now we put that in float. Now it's promoted to the floating point number 65.0. And this example, we have the 1 and we have a floating point in the expression. So the 1 is automatically promoted to a floating point number in order to do this division. So it evaluates to 0.333. Operator precedence. The different types of operators, normally it goes left to right. So if you say A plus B plus C plus D, it'll do A plus B first, it'll add C second, it'll add D third. But you can change the order. You can change the order with parentheses, or if it's inside of a square brackets for indexing into an array. So the first things that are done is the unary operators. So if you have A minus C++, the C++ will be done first before subtracting from A. Typecasting is done next, multiplicative, then additive. So A plus B times C, that's a times. This will be done first and then A added, because multiplicative has higher precedence than additive. Followed by the bitwise shift, which can occasionally cause you problems because the precedence is not changed if you're using this for outputting to output streams or inputting from input streams. So this precedence remains the same no matter what that operator happens to be. And then your comparator is next for non-equal. Equal is the next, then logical or ternary, and your assignment is your bottom. If everything else is equal, it just goes left to right. And we have some expressions. Expressions when you take a bunch of values, which can be literal values or they can be variables, and you glue them together with operators, such as plus, multiply, etc. So an expression is a combination of variables, constants, functions, other expressions, which could be inside of parentheses, could be function call, and they're connected by operators that could be evaluated to get a value. 17 evaluates to 17. 15 plus 2 evaluates to 17. 15 times 2 divided by 3 evaluates to 10. I'll let you check that math. Here we have integer A is 100, B is equal to 2,000. A is less than B. That expression evaluates to true. B divided by 1,000. Now, remember our precedence. This is done first. And this is done next, and then that. So B divided by 1,000, what was it? 2,000 divided by 1,000, that's 2. Is greater than or equal to 1? Yeah, that evaluates to true. A is 100 is less than true, it also evaluates the true. So true and true evaluates the true. Whew. B plus 1,000, now the division is done first, so 1,000 divided by 1,000 is 1, added to B, which is 2,000, that evaluates 2001. Well, that wasn't what we wanted, that wasn't what we meant. This is what we meant. We put parentheses around it, so the parentheses are done first, so B plus 1,000, then divided by 1,000, that evaluates to 3. And a few more cautions here. It's particularly on the increment operator. Try not to use the increment operator more than once on an expression, because that can cause all kinds of heartburn. Here's a classic little example. You got A plus plus multiplied by 7 plus 9 times plus A, huh? So I'll let you try that at home for homework, and I'm almost willing to bet you real money that you will not be able to predict what that answer will be. We print it out. So give it a try and see. So your best bet in most cases is just to use it on a line by itself. There's no ambiguity. There's no problems. It works beautifully. But when you do this kind of stuff, you're asking for confusion. Anytime you're in any doubt about precedence, we'll do this one first, we'll do that one first, don't worry about it. Put in parentheses your intended order of evaluation. So here we're putting minus 7. You think, well, is unary minus before multiply? Well, no, actually the unary 7, the unary minus will be done first. But just in case, we'll put it inside parentheses. It makes it less confusing. Multiply by 9, blah, 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 blah. So all these wonderful parentheses are put in there to make sure that the precedence is explicit. And it doesn't hurt. The compiler doesn't care. It'll be just as fast when it executes. But when, like I say, when a human reads it, human readability is more important than computer efficiency because you spend more money on programmer time than you spend on computer time. So whenever in doubt about precedence, add parentheses. Sometimes they really are necessary because if you want the plus to be done first, you have to put it inside parentheses, otherwise it won't be done first. Oh, wait a minute. That's the wrong kind of operator. Well, that's it for today's class at educated.com. I will see you next time.